All right, let's just jump right into it. If you're building anything with AI, you know this feeling, right? You tweak a prompt, you run it again, and you kind of think it's better. Well, today we're going to talk about how to completely transform that guesswork into a real, systematic, data-driven process, so you can stop guessing and actually start knowing.
I mean, this is the big question, isn't it? You go in, you change a model, you adjust some parameter, or you rewrite a prompt, and you do it all with this hypothesis that it's going to improve the output. But how do you prove it? How do you get past that gut feeling and into solid ground?
This slide pretty much sums up the entire shift we're talking about today. We are leaving that world on the left, the subjective, random, I'm not really sure world, and we're moving over to the world on the right. A world that's methodical, objective, and gives you proven results.
So here's our game plan. First, we'll dig into the problem itself. Then we'll lay out the new rules for evaluating AI. After that, we'll talk about the crucial role of data. And then we're going to walk through 2 real-world examples to see how this whole thing actually works in practice.
Just think about the last time your AI agent wasn't doing what you wanted. You probably dove into the prompt, right? Changed a whole bunch of things at once and then hit run. Now, if it got worse, you had no clue what broke it. And if it got better, you didn't really know what specific change made the difference. That right there is the problem with guessing. And it's exactly why we need a better way.
So, let's talk about the solution. This is where we start treating this like a real discipline. We call it workflow evaluation, and it's basically the science behind building better, more reliable AI systems.
At its heart, this is all we're doing. It's actually pretty simple. You have a hypothesis in your head. If I do this, the output will get better. Evaluation is just the formal process of using data to get objective proof that your hypothesis was either right or wrong.
And this brings up a really key point. You can't just use your old software testing methods for AI. It just doesn't work. Why? Well, for one, AI models are kind of like a black box. They're probabilistic, not deterministic. The same input can give you different outputs. On top of that, you've got these models that are constantly evolving, and you have to optimize for cost, and for time, and for bias. It's a whole different ballgame. This complexity demands a totally new approach.
Really, it all boils down to this one simple mindset shift. You have to stop thinking like a tinkerer and start thinking like a scientist. Every single change you make isn't just a random tweak anymore, it's a controlled experiment.
And here's what that experiment looks like. It's the good old scientific method. You form a hypothesis, something like using a different model will increase my accuracy. Then, and listen, this is probably the most important part, you change only one variable. Seriously, just one. Because if you change the model and the prompt and the temperature all at once, your data is basically useless. You have to isolate that one change, run your test against a consistent data set, and then you can analyze the results and know for sure.
Okay, so this brings us to what is, without a doubt, the single most critical piece of this entire puzzle. Because without this, none of that science works. Your data, that is your compass. It's the only thing that tells you if you're actually heading in the right direction. I really love this quote because it just says it perfectly. Your test data set is your ground truth. It's the solid foundation, the benchmark that all of your experiments are measured against. And if your ground truth is flawed, guess what? All of your results are going to be flawed too.
So what makes for a great data set? Well, here's a quick checklist. It's got to be accurate and consistent, obviously, but it also needs to be comprehensive. It should actually represent the real world, including all those tricky edge cases. And, super important, it has to be large enough so that your results are statistically significant, not just a fluke.
So how large is large enough? Well, when you're just getting started, in that early testing phase, a solid set of about 50 to 100 high-quality examples is a pretty good place to begin. But once you start getting serious, as you get closer to production, you've really got to scale that up. We're talking 250 to 750 examples to make sure you're covering your bases.
And then, for those mission-critical systems, the ones where failure is just not an option, you need to be pushing past 1,000 examples, easy. The more data you can test against, the more confidence you're going to have.
Okay, that's enough theory. Let's look at a real practical example of this evaluation loop in action. This is a fantastic little case study of an email agent, where one simple data-driven fix made all the difference in the world.
So the task itself is pretty straightforward. You've got an AI agent that needs to read an email and then assign it 2 things, a category, like billing or support, and a priority level. Simple enough.
So,
They ran their first test against their dataset, and these were the results. And yikes, look at that. The priority accuracy was, okay-ish at 67%, but the category accuracy was a total disaster, 0%. The data immediately screamed at them, pointing to exactly where the problem was.
So they looked at the failed outputs and formed a really simple hypothesis. The AI was messing up the categories because it didn't know the exact names it was supposed to be using. So the fix was to make one and only one change. Add the list of valid categories directly into the system prompt.
And here are the results after they ran the evaluation again. Boom. Just like that, category accuracy jumps from 0% to 100%. This is that aha moment. A single targeted change, completely guided by the data, totally solved the problem. Now they know exactly what worked and why, and they can move on to fixing that 67% priority accuracy.
Now that first example was pretty cut and dry. The category was either right or it was wrong. But what about those more complex, more subjective tasks where there isn't just one single correct answer? Well, this is where we can pull out a more advanced technique.
So the challenge is, how do you objectively score something like the helpfulness or the tone of a generated email? The solution is actually fascinating. You use a separate AI model to be an impartial judge. As long as you use the exact same judge model for every single test, you can get consistent, comparable scores for these really subjective outputs.
And this right here is where this whole evaluation process really pays off. I mean, just look at this table. It makes the entire decision crystal clear. They tested two models. The AI judge gave Google Flash a higher accuracy score, 4.3 out of 5, not bad at all. But on top of that, it was also about 50% faster, and it costs less. I mean, come on. The data makes the choice a total no-brainer. Without an objective scorecard like this, you'd just be guessing.
So if there's one thing you take away from all this, it's this. Building great AI is all about moving from subjective hunches to objective proof. It means treating every single change like an experiment. So the next time you want to improve your workflow, don't just guess. Ask yourself this exact question. What is the one variable you can isolate and test this week to finally move from just guessing to actually knowing you're making things better?